Security. I checked the program, the one and only security talk for this conference, so I hope you'll enjoy this one. And if you want to know more about security, I'm going to tell you up front, try to grab me during lunch after the talks, and we can chat about security. I'm Philippe De Ryck, image source none, on error something something. You probably recognize this. Some HTML code, that's essentially not my name, but that's what I can put in your application as my name. That's something that you probably don't want happening in practice, because as you can guess, the image part is not my real name. I can show you my passport, it's not in there. My parents screwed me up enough with my normal name, so that's already one challenge here. But if this ends up in an HTML page, that might be a problem. If this ends up in an HTML page and the browser sees that image part, which is part of my name, guess what the browser is going to do? Your browser is going to be like, oh, an image. I'm going to try to load that. And of course, it doesn't exist, so the browser is like, oh, here's an error handler. Let me execute that. So if I change my name to this on the NGDE schedule, website, whatever, not that I can edit my own things, but if I could do that, and you would visit that, you would see my name with that malicious code that executes in your browser, and you are in trouble. Because I, as the attacker, can now control code in your browser, and it can mess up the application in your browser. It can do a variety of things. Essentially, the attacker, with a cross-site scripting attack, an alert, not really dangerous. That's annoying. It's just a proof of concept. The alert is to prove that the attacker can execute something very visually, like, hey, this is executing, but it means they can do anything they want in your front-end application, and as a user, you have now become a victim. A couple of stories to just make sure that we understand the true impact of cross-site scripting before we dive into details. Here's an app that allows you to track your children for security purposes, except that it had cross-site scripting vulnerabilities, which also allowed people with bad intentions to track your children, not for security purposes in that case. So that's kind of not the best way of doing things. Massive problem, kind of fully circumventing the whole idea of the app. Facebook has had its history with cross-site scripting as well. In this case, a story through bug bounties, but they paid out $25,000 US for somebody finding a DOM-based XSS, just to give you an idea of how important these vulnerabilities are. And another story, again from Facebook, in this case, the Oculus accounts, they could be taken over, and this researcher got $30,000 USD for reporting that vulnerability. Just so you have an idea that cross-site scripting, even though we always show that alert, it's just a proof of concept. It's a real vulnerability with real risk for which companies pay real money when you find and report them in a bug bounty program. All right. In this talk, I'm going to talk about trusted types. And I'm going to make you a big promise here, because these vulnerabilities are DOM-based XSS. That's what we call them. It's basically when your Angular app in your instance, your Angular app screws up, or the developer screws up usually, and Angular inserts data into the page, and all of a sudden it triggers the execution of JavaScript. That's a DOM-based XSS. And I'm going to talk about trusted types, and trusted types will have the ability to eradicate these vulnerabilities from your applications. That's a big promise. That's something that is massive and that we cannot do or haven't been able to do in the past 15 or 20 years. And trusted types is a piece of the puzzle that will make things a lot better, and that's what I'm going to talk about. Before I do that, small word about myself. I'm Philippe De Ryck, I'm from Belgium, and I'm a security expert. And I run my own company called Pragmatic Web Security, through which I help other people build more secure web applications. I give security training, like in-depth, hands-on security training. I speak at conferences, I have online courses, and I consult with companies on specific security topics, often very complicated things like OAuth, OIDC, API security, and front-end security. I'm also a Google developer expert and an Auth0 ambassador. DevRel programs, it's kind of an outreach program where they appreciate the stuff I'm doing for the community, like conference talks and blog posts and so on. And they send me free swag every now and then. So that's kind of our working relationship there. I'm not employed by these companies. By the way, Auth0 is here with a booth. Go check them out if you're interested to learn what they're doing. But back to this guy. Back to this user with a very malicious name. So let's talk about Angular, right? I'm kind of assuming, since you're here, you're Angular developers, or maybe the React devs wanting to look at the other side of the fence. But in that case, Angular is awesome. So, but if you put this in a page with Angular, guess what's going to happen? Well, you have this data interpolation, a variable. You insert the name into an HTML context in this case. And Angular is not a stupid framework. Angular knows exactly what you're trying to do. And it's like, hold on. That's kind of dangerous. That's not really a good idea if I just drop it in there and God knows what can happen. So Angular is going to automatically escape that data to make sure it's safe. So if my name ends up there, the open bracket for HTML elements will become %LT semicolon, and so on and so on. And the browser is going to be like, okay, you want me to show that character? I'll do that for you. And nothing bad is going to happen. And before you start doing like a party dance, Angular is so awesome, all the other frameworks do it as well. So this is something that's done in React and in Vue. And if you happen to find a framework that doesn't do this, my advice is to drop it and find a better one, because this is absolutely the basics. Like if a framework can't do this, you're in a real big trouble. All right, good. Easy. Problem solved. Well, mostly yes. For names, like the name of a user, you typically don't trigger the rendering of HTML. But at some point, you'll have the need to render HTML. For example, if somebody has a CK editor document, behind the scenes, this pretty document is HTML. It's headers and paragraphs and images and captions and block quotes a bit lower and so on and so on. And if you want to render that, you need to tell the browser, hey, this is HTML. You don't have to just show the characters. You actually have to render that as HTML. And in Angular, we have an inner HTML property to do that. Inner HTML. So we assign a value to that property, and it will end up in the page as inner HTML. The browser will trigger the HTML parser. And Angular doesn't just expose the native underlying inner HTML property. It has its own property, and it has a step in between. It sanitizes the data first. So what Angular is going to do, Angular is going to look at the data and be like, hold on, this is dangerous. You know what I'm going to do? I'm going to walk your HTML document step by step, and I only allow elements and attributes for which I know that they're safe. So that image will be there, but the on error that I added to my username, the Angular sanitizer will be like, no, that's not cool. I'm going to throw it out. Awesome. This is the moment you do that happy dance, by the way, because Angular is the only framework that does this out of the box. Yes. Thank you. If you tell that to React developers, they're like, we don't care, whatever. All right. That's a side note, by the way. So what happens under the hood? Well, you're building your application. We have a line here. On top of the line is your application code. You have your data coming in, your application code where you bind it into the page with escaping or that inner HTML property in Angular. And under the hood, underneath that application code, the browser is going to assign that data to what we call a dangerous sink. We're basically assigning that to inner HTML or outer HTML or whatever under the hood, and that will result in the invocation of the HTML parser, which will render you a pretty document in the browser. And that's awesome. And that's secure by default as offered by Angular. And this is really good. However, Angular doesn't prevent you from not screwing up. So at some point in time, you're going to have a code path that bypasses this escaping or sanitization step. It's going to end up in a dangerous sink. The HTML parser is going to find a piece of JavaScript somewhere in various ways that can happen. It's going to throw it to the JavaScript engine, and the browser is like, ooh, let me execute that. And you have your cross-site scripting vulnerability. That's not good. By the way, this happens in Angular applications. Every time I teach an Angular security workshop, I talk about cross-site scripting in a lot of depth, and I can almost guarantee that during the break, one of the attendees comes to me like, yeah, we looked at our application, we kind of found a cross-site scripting problem, even though Angular does things out of the box. So how can you mess this up? How can you sidestep Angular's protections? Well, there's a function called bypass security trust HTML. Guess what that one does? This function tells Angular, like, you know what? You don't have to secure this. I'm vouching for the security. Well, that's the idea. Developers are using this to bypass Angular security without fully understanding what it does. And if you assign this to inner HTML, the Angular version, you have a cross-site scripting vulnerability, or likely have a cross-site scripting vulnerability. That's a bad pattern, which happens very frequently, by the way. How else can you do it? Well, Angular has this Vue child with element refs. That should scare the crap out of you, because this allows you to escape the Angular layer, where Angular is kind of protecting you, and drop down into the native DOM APIs, where you can now do all kinds of crazy things that you're never supposed to be doing, such as grabbing the native element and assigning something to inner HTML. Not a good practice. Don't write code like this. The Vue child is not a problem here. Sometimes you need that reference. It's that inner HTML property. That's an unprotected raw access. Angular is not in the loop. Angular will not protect you when this happens. Not good. And there's the third way. There's a renderer2 API that allows you to have similar interactions without actually using DOM elements. So you can set properties like inner HTML, and that causes the same issue. So the takeaway here is that cross-site scripting in Angular applications is not impossible. Yes, Angular has secure defaults, which is awesome. And if you follow the Angular way of doing things, you are protected. That's really good. But there are, unfortunately, still ways that things can go wrong, and they actually do go wrong in practice. And that's the setup of what we're going to talk about right here. How can you stop things from going wrong, even accidentally? That's where trusted types comes into play. What is trusted types? Trusted types is a browser security mechanism that you can enable by setting a security header. You can send the browser a header that says content security policy, that's the name of the header, with a directive, require trusted types for script. And that tells the browser, I want you to enable trusted types. And what that does in the browser is that changes that DOM API, that dangerous sink, into a safe sink. As in, that sink, inner HTML, no longer accepts text-based data to transform it into HTML. No, it accepts a trusted HTML type. So when you assign something unsafe to that sink, the browser is like, yeah, no. Nice try, but no developer, I'm not going to do that. You're trying to set text to inner HTML, and I only want trusted HTML types. Boom. It blows up, and it doesn't assign that, and it basically, well, it breaks something, but it also protects you. And this mechanism came from Google. So Google has been using this internally for about a decade now, and they saw really good results, and they decided to port that to the web platform by adding it as a browser feature. And one of the results that you should read the document, it's really good. One of the results is that they tried static analysis to find these vulnerabilities, and they couldn't find all of them because, well, guess what? JavaScript code is a mess, basically. But, well, I don't have to tell you that. But trusted types, when they started using that, actually solves their problem. And in the application where they have enabled trusted types, they haven't observed any DOM-based XSS vulnerabilities anymore because it's that powerful. Absolutely awesome. So, trusted types only affects when you invoke the browser's HTML parser. It doesn't really care about using proper APIs because there's no confusion there. There's no text that gets translated into HTML code. So whenever you write something like create element, set attribute, text content in this, that is unaffected by trusted types. There's zero impact when you do that right here. It only impacts locations where you transform text-based data, like a CK editor document or whatever, into HTML. That's where trusted types comes into play. All right. So how does trusted types work with Angular? Well, Angular has trusted type support built in. Seriously, it's not enabled by default. You have to enable it, but if you want to enable it, it's like, hey, Angular, let's use trusted types. And Angular's like, okay, done. What this means basically is that every time you assign something through the Angular sanitizer, Angular will transform that output of the sanitizer into a trusted HTML type, and the problem is solved. Because now you enable trusted types, you tell the browser, we want to allow the Angular policy. You add that on line 3, trusted types Angular. There you define a specific policy, a policy built into Angular. You tell the browser, like, whatever this policy says is safe, just accept it. And that's it. You have now enabled trusted types for your application. Everything you've done the Angular way is going through unchanged. It will be assigned into the DOM. And if you run into that use case or in that mistake, if you copy-paste the wrong code from Stack Overflow, basically, and it sidesteps the sanitizer, trusted types will be like, hold on, no. We don't use bypass security trust HTML here, or no, we don't assign things into the inner HTML of a native element using the view child. Absolutely not. And trusted types will catch these things for you. Awesome. This is absolutely awesome. Trusted types, it doesn't really apply security. It doesn't really magically transform your application to become a secure application. But here it forces you to not do, how do I say this carefully? Dangerous things. That's the right word, dangerous. So it forces you, whenever you make a mistake, which we all do it, this is just the way things happen. Whenever you make a mistake by accidentally using bypass security trust HTML or a native inner HTML property, trusted types is going to be like, hold on, no. That is not right. We're not going to do that. And you basically get a trigger like, oh yeah, whoops, my bad. And you can fix the code and the problem kind of goes away. And I can hear some of you thinking like, yeah, but I do use bypass security trust HTML and I want to keep using that. I like some danger here. So, well, in that case, you can tell the browser, with your trusted types configuration, like, yeah, this bypass security trust HTML, that's also kind of fine. You have a policy built into Angular for that. It's got the Angular hashtag Unsafe Bypass policy. And it re-enables bypass security trust HTML, but it cannot protect you against dangerous uses. So that means you have to vet every use yourself before you enable that to make sure that you use bypass security trust HTML in a legitimate way, in a safe way. That's essentially your responsibility now. So I don't really recommend enabling this unless for these very specific odd cases where you have no other way to get done what you need to get done. That's what trusted types does. It avoids unsafe DOM assignments, like unsafe assignments to an inner HTML or an outer HTML property. That's what trusted types brings to the table, and it avoids, or it helps avoid, a lot of these coding mistakes. All right. Everybody excited? Yeah. Awesome. Let's talk about browser support. Well, it used to be, damn it, IE, what are you doing? But now it's like, damn it, Safari, what are you doing? And this is a Chrome mechanism, it's a Google mechanism, it's built into Chrome, of course. I mean, it's kind of obvious. And so the Chromium-based browsers, Edge, Brave, Opera, they all have this feature, but the other browsers do not. Now, I got you all excited for nothing, it seems. But this is actually not a problem. Let me ask you why. Who here uses a Chromium-based browser for development? All right, everyone, right? Here's what happens when you build an application. You're developing, you're using Chrome or whatever, Brave. I'm a fan of Brave, by the way, awesome browser, so I'll look into that. And you enable trusted types in your development mode, and your browser is going to be like, okay, let's do this trusted types thing. And you copy-paste some code from Stack Overflow, and you put it in your application, and you get this, and your browser is going to be like, seriously? No, let's not do that. And it will give you a nasty error when you do that. And instead, you're like, oh yeah, whoops. My bad, Monday morning, shit happens. So you fix your code, you write it a proper Angular way, or you invoke a separate sanitizer like DOM Purify, whatever. You get a trigger to fix your code because this is something really dangerous. And your application becomes better and more secure. And then you deploy that. And your friends are like, yeah, Firefox is awesome, we use Firefox. And they don't have trusted type support. But guess what? Your application is now secure. You fixed your application up front. So because of that, your application is more secure, and browser support doesn't really matter that much. My recommendation for now is use trusted types in dev mode. There's no real need to deploy it in production mode. You can do it in development mode and just find these mistakes in your application code and fix them. That's awesome. And if you really want, there are polyfills available that do offer trusted types in non-supporting browsers. So you can load a polyfill in Firefox or Safari that will add these APIs through the polyfill, and you can now use trusted types as well in your application on all browsers. All right, brings us here to the takeaway. Trusted types improves code security, and that's the main benefit. That trigger will help you improve the security of your application code to ensure it is properly secured. And when you do that, you end up here. No more bypasses and mistakes. Everything is secure. Awesome. If you get there, this is, by the way, not unfeasible in Angular. That's one of the awesome benefits of being secure by default. So if you get there, you have done a great job. But of course, you also know that of your entire application, you only write, what, like 2% of the code, maybe 5%? So we have a lot of third-party code dependencies. And guess what these dependencies do? They do all kinds of crazy things like assigning data into the DOM. Well, wait, this doesn't look right. Yeah, that's better. Lots of third-party dependencies. And even something silly as Bootstrap rendering a tooltip in your application can trigger cross-site scripting vulnerabilities. And that's a bit of a problem. Because guess what? If that happens, you're screwed. Sorry for the language, you are in trouble, or your users are in trouble. But it's not like you can start patching Bootstrap. That's not a really feasible way forward. Like, oh yeah, let's just patch every library that we have when there's a potential weird vulnerability somewhere. So that doesn't work well either. And that's where trusted types comes into play. Because trusted types is a platform-level defense. If you enable trusted types, guess what? That Bootstrap framework is using the DOM APIs that you have transformed into safe APIs. And the browser will be like, no, I'm not assigning text as a tooltip. I simply won't do it, which is good because it protects you. It's also bad because it doesn't give you the tooltip that you want. It just gives you errors instead. And that's where the final piece of the puzzle comes into play. Like, this is good as a defense, and if you really want to make it even more secure, you can enable trusted types in production this time in a default policy mode. So you can specify a default trusted types policy, as you can see in the bottom block here. You just call it default. That's kind of a convention with trusted types. If you call it default, the browser will take every unsafe assignment. Like if Bootstrap is trying to assign text into the done browser, it's like, oh, fine, you know what? I'll just transform it into a trusted type myself. And it feeds it through the policy calls the create HTML function on line 6, where you have a string as input, and you can do whatever you want with that string. In this case, we're using dump purify, a JavaScript-based sanitizer, really good one, by the way. We're using dump purify to sanitize the string ourselves to make sure it's safe before we assign it into the page. And that kind of allows you to apply a policy by default. And that is really, really awesome. This piece of the puzzle here is great. I don't recommend to use this as a default because I know how I'm a developer myself. You try to find the shortest way to the place you want to be, the shortest path possible. So don't be like, oh yeah, I'll just slap the default on everything and I don't have to worry about fixing my application code. Please don't do that. As in, it's still recommended to actually fix your code, to write code in the best possible way, and default policies are only useful for in those odd cases where you can't fix the code, or in the horrible case of like a super legacy application that you don't want to change the code because you can't build it anymore for God knows what reason. These things exist as well. So adding a default policy there might be not a bad solution. So trusted types is a browser-level measure. That's basically what this means. And it prevents third-party code dependencies from doing unsafe assignments if you enable this. Code you have no control over, all of a sudden you can say like no, or we'll fix it for you. And that is absolutely beautiful. Brings me to 3 important takeaways. This is the stuff you have to remember. Everything else you can look up afterwards, but these are the things you want to remember from the talk. By the way, the slides are on my website. I should have tweeted about that as well, so look them up and grab them for later. Angular supports trusted types out of the box. So that's great, as in Angular has configured their sanitizer to return trusted types when necessary and so on. Awesome. You can use that by just enabling trusted types and allowing that Angular policy to be used for creating trusted types in the browser. Great. My advice is to enable trusted types in development. Try it out. If it comes back with like 15 errors, that's 15 places you want to look at to see what the hell is going on there. 15 potential vulnerabilities, by the way. So really look into that, figure out like, why is this throwing an error? Why are we not feeding this through the Angular sanitizer? And make sure that what you're doing there makes sense and is secure. And try to find a way to fix it without, so that you can solve that error message, basically. And then finally, you can use a default policy when it's impossible to fix the actual code. That's just a fallback. I don't recommend that as a default approach because this also requires polyfills, by the way. If you want to use that default policy, you must have that polyfill loaded in the browser. All right. If you want to read up on this afterwards, I've also written a guest post for the Auth0 blog where you can read up about securing single-page apps with trusted types, has some policy examples and so on, maybe in a few more details than what I was able to cover here. If you want to learn more about security, I'm running 2 security workshops with Manfred Steyer. Well, I'm running them. Manfred is just slapping his name on there, but don't tell him I said that. But or actually tell him he's fine. He can deal with that. But it's an Angular security workshop and an API security workshop, since most Angular apps have APIs behind them. So check them out if you want to. Thank you for being here. Connect with me on Twitter, on LinkedIn, and grab me during lunch after the next talk. And we can have a chat about security or any other topics, basically. Awesome. Thank you.